Have you ever seen a sprinkler zone that keeps running long after the controller shuts off? Or worse, one that never turns on at all? Both issues often come down to one small but mighty component, the zone valve. I'm Dr. DeBusk, and in this section, we'll take a closer look at one of the most important and often overlooked parts of an irrigation system, the zone valve. Zone valves act like the switches of the irrigation system. They control the flow of water to each zone, opening and closing based on signals from the controller. When these valves malfunction, they can cause serious problems, from flooding landscapes to killing turf through lack of water. In this section, we'll learn how to properly inspect, test, and maintain zone valves to keep the system operating reliably and efficiently. Often, irrigation technicians will check a valve's operation simply by turning it on and off from the controller. That's quick, but if you don't know where the valves are located, you can't inspect their physical condition. While it's tempting to stop there, this can be a costly shortcut. A valve that fails to shut off could flood a property, while one that fails to open can stress or kill expensive landscape plants. That's why even limited preventative maintenance, like reviewing and documenting valve performance, has an excellent return on investment. In this section, we'll look at 4 key components to include in a complete valve review: the zone valves, filters, wires and splices, and valve boxes. You'll see these reflected in the irrigation service checklist that follows. Zone valves, also known as solenoid valves, act as the electrical switches of the irrigation system. Each one controls water to a specific zone. As we review valves, we look at 2 things: how they operate and their physical condition. You'll start by turning the valve on and off from the controller. It should open promptly, allow water through, and then close completely when turned off. If it doesn't respond, you may need to operate it manually at the valve itself. Pro tip: always check the valve operation while you're observing the sprinklers. That saves time and helps you connect performance issues like weak pressure or weeping heads to potential valve malfunctions. Finally, make sure your observations are recorded using your company's reporting process. Now, how do you know if a valve isn't closing completely? If you see puddling or wet turf near the lowest sprinklers, especially when the system hasn't run for a while, you might have what's called low head drainage or a weeping valve. You can confirm this by turning on the valve, letting it run for a bit, and then turning it off. If water dribbles from one or more sprinklers about 5 minutes later, that valve isn't sealing properly. Be on the lookout for indirect signs too: algae growth on sidewalks or reports of higher water bills. A key efficiency tip: always double check that your main water source is on before testing valves. Many misdiagnoses happen because the water was simply off. When inspecting the physical condition, you'll likely need to open or dig out the valve box. Look closely for any leaks around the solenoid, between the bonnet and valve body, or at the fittings leading in or out of the valve. Algae or corrosion can signal a long-term leak, and damaged screws often mean someone tried tightening them without success. Technician's note: don't assume a valve box full of water always means a leak. Water can easily flow downhill into that box from another area of the site. Always investigate before assuming the valve is the culprit. Filters at zone valves are most common on drip irrigation zones, but you may also find them on other valves, especially in systems that draw from ponds or wells. Their job is simple: to trap debris before it can clog emitters or nozzles. But like any filter, they only work if they're kept clean. During your maintenance visit, inspect the physical condition of the filter. Look for leaks around the housing or fittings. If there's an external flush valve, open it to rinse out debris. At least once a year, you'll want to disassemble the filter. Remove the screen, discs, or basket, clean or replace them, and reassemble the housing tightly. Technician's tip: since the filter is located right by the zone valve, combine this step with your valve inspection to save time and ensure the system is fully evaluated. And as always, record your observations using your company's established reporting process. The solenoid and wiring at each valve are the electrical heart of the irrigation system. When a zone fails to turn on or won't shut off, wiring issues are often the culprit. While the actual ohms testing is performed when you check the controller, this part of the preventative maintenance call focuses on the wiring at the valve box itself. You'll start by locating and carefully exposing the solenoid, valve wires, and any splices. Inspect the wire jackets for cracks or cuts, and make sure no bare wire or conductor is showing, especially where the wires enter the solenoid. Next, focus on the splices. They should be waterproof and fully sealed. If you find electrical tape, duct tape, or wire nuts dipped in PVC glue or silicone, that's a red flag. Those methods are not waterproof and must be replaced. Technician's tip: once a waterproof connector has been used, it cannot be reused. There won't be enough sealant left to maintain the waterproof seal. And remember, these wire and splice checks should be performed at the same time as your valve condition observations to make your inspection more efficient. Valve boxes might not seem like a big deal at first, but they play a critical role in protecting the irrigation system. Think of them as the vault that keeps your valves and wiring safe from damage, weather, and curious hands. A cracked lid or deformed box can expose wiring and create liability risks for tripping or shock. It also makes routine maintenance more difficult because you may have to dig the valve out each time. During your inspection, start by checking the lid for damage and making sure it fits snugly. Look for exposed valves or wires inside the box, and if you're working on a commercial property or sports field, confirm that the locking bolt or mechanism is working properly. When you're done, always replace the lid securely to prevent accidents and vandalism. A simple step like that keeps the system safe and professional. Finally, after inspecting all valves, filters, solenoids, and boxes, it's time to document your findings. Every company has its own reporting method, but accuracy and clarity are always key. Here's an example. All 5 zones were tested. Most were fine, but Zone 1 needed 3 new waterproof connectors. So we mark it with a 3 and note that it was repaired now with a check. Zone 5 was missing a valve box lid, so we marked it with 1 but left it unrepaired since the technician didn't have a spare. Zone 1 was a drip zone, so the filter section was marked OK while the rest are NA. The goal isn't just checking boxes. It's creating a record that shows that it was inspected, what was fixed, and what still needs attention. This record helps the customer understand the service they received and helps the next technician pick up right where you left off. Let's wrap up this section with a quick review. Zone valves are the heart of each irrigation zone, controlling when and how long water flows. A thorough inspection includes not just testing if the valve turns on and off, but also checking its physical condition, the filters, the wiring, and the valve box itself. By combining all of these checks during one service call, technicians save time and prevent small problems from turning into expensive repairs. And remember, documentation is part of the job. Your notes and reports prove what was done, help the next technician, and build trust with the customer. Preventative maintenance isn't just about fixing things, it's about keeping systems reliable, efficient, and professional.